next important concept we will discuss is data structure. Whenever this term structure comes, what comes to our mind is organization. So what is data structure? It is organization of data, management of data, and storage of data to enable efficient access and operation. The data that we have, we need to organize it well so that we can properly manage it, properly process it, properly store it, properly retrieve it. That is very important. And various operations which are possible are addition, deletion, searching, sorting, modification, etc. Efficient data structure allows faster data processing and faster data retrieval, which is very, very crucial for the performance optimization of algorithms and applications. There are broadly two types of data structure. One is linear data structure, another one is non-linear data structure. The linear data structure, it stores data in a sequential or linear order or fashion. Various types of linear data structures are array, which is a collection of elements stored in a continuous or sequential memory locations. Another popular linear data structure is linked list, which is a collection of nodes where each node contains data and a reference point which is known as pointer to the next node. Another example of linear data structure is a stack or queue. They are data structure with a specific order. A stack follows LIFO scheme. LIFO stands for last in, first out. Say if we have a container like this, we keep on adding things. So whatever will enter last will come out first. And Q is a FIFO data structure type. Means FIFO means first in, first out. So it is something like this. We have a pipe. Whatever is entering first will come out first. Next is non-linear data structure, which stores data in hierarchical or interconnected forms or network forms, and it is not sequential. Trees and graphs are example of non-linear data structure. So this is a summarized form: linear data structure, array, linked list, stack, queue; non-linear data structure, tree, graph, hash table; application, sequential data management; and application of non-linear data structure, hierarchical and interconnected data. Next is data file, data or file format and standards. What is a file format? It is a standard way of encoding information for the purpose of storage in a computer file. So the files which store data, we all talk of text files and image files and video files and database files, right? So they are all formatted in a way which allows for efficient storage and access. For example, if you use Notepad, you will store it and you will find whatever name you give, the additional name which is given to it by the system is .txt. So it says that it's a text file. We have just discussed about audio MP3. It is another file format. What is the importance? Different types of data require different formats for storage and manipulation and understanding these formats is key for handling multimedia contents and files. Say for example, some of the common text formats JSON or XML or CSV. JSON is JavaScript object notation. File extension name is .json. XML, extensible markup language, which encodes documents in a format readable by humans and machines. You will find this additional name .xml. CSV file, very common. It is a comma separated value and the extension name is .csv. These formats ensure what interoperability and compatibility across the different systems and different platforms. In the same way, data formats for web, HTML stands for hypertext markup language, CSS, cascading style sheets. We have just discussed about JSON and XML. In the same way, for images and videos, the popular file formats, we discussed about it, JPEG, PNG, GIF, these are all very popular image formats for images. JPEG is popular for pictures and it uses lossy compression to reduce the file size. GIF used for animation. PNG supports transparency and it uses lossless compression. We have already discussed about lossy and lossless compression. In the same way, MP4 and AVI, they are all examples of video file formats. Text formats, plain text, CSV, JSON, XML, YAML. It is used for storing simple or structured text data. Binary formats, we have protocol buffers, HDFS, Parquet, binary files. Image or audio formats, we have discussed document formats like .doc or .docx, .ppt, .pdf, .odt, .xls. So these are all formats we are very familiar with. Web standards, HTTP, HTTPS, SOAP, REST, data interchange formats, CSV, JSON, XML, YAML, these are all files which it is for interoperability. So we just discussed about it. In the same way, for data modeling, we have UML, ERD, JSON LD, XSD. Security standard are there. Now, next is file systems and data storage. The file systems and data storage concepts are essential components of computing because they define how data is stored, how data is organized, and how data is retrieved on the storage devices. We know about various storage devices. A file system is a method or a structure which is used by the operating systems to organize, to store and to retrieve the stored data from various storage devices. Some key components of the file system. One is file. We generally very commonly use this term file. It's a collection of data stored together in a single unit, like the files that you create in MS Word. in Excel, in PowerPoint, right? In the same way, the files that we create in Notepad, in the same way, image files, in the same way, video files and other files. Directory, it's a very common term which we use. It is which we use, and it is what? It is a container which holds individual or many different types of files. So, it organizes files into a hierarchical structure, and thereby it enables what? Easy navigation, management and access to those files. Next term is metadata. Metadata is data about data. Information about the files, including the name of the files, the size of the files, the permissions that the file has, the creation date, the modification dates, location information, path or directory where that file is located. All such informations are known as metadata. As we discussed that file systems are very important concept in operating systems, and some of the very popular file systems are FAT, file allocation table, which is older file system for a smaller disk. Its variants are FAT32, XFAT, etc. Another very well-known file system is NTFS, New Technology File System, which is a modern file system for Windows operating system, and it supports large files and many advanced features. EXT, Extended File System. EXT4 is optimized version for the large volumes and solid state drives. APFS, Apple File System. Apple has introduced for its operating system Mac OS and iOS the APS file system. One more file system is ZFS, Zettabyte File System, which is a high performance file system which is commonly used in high-end servers. Next is data storage. What is data storage? The methods and technologies which are used to save data in digital form onto some medium, right? There are various types of data storage. One is primary data storage, another one is secondary data storage. We have tertiary data storage as well, we will discuss about it. We all know that primary data storage uses IC, integrated circuits, and the memory formed by these circuits, they are volatile in nature. Random access memory, RAM, which is a fast and main memory of the computer system. It's a temporary storage and it uses the current data the CPU is working on or it is processing. Another type of primary memory is cache memory, which is a small size, very high speed memory located inside the computer system, either on board or on the chip, CPU chip, or in the chip within the die. So, we have accordingly three different types of cache memory: L1 cache, L2 cache and L3 cache. L1 is on-board cache, L2 is on-chip cache and L3 is in-chip cache. Cache memory holds the most frequently used or accessed data for quicker access, and it is very important in a computer system or in digital system. Secondary storage or bulk storage, also known as non-volatile memory. Why? Because it does not lose its content when the power is switched off, as opposed to RAM, which is volatile, or the other primary memory which is volatile. Why? Because when the power is switched on, it loses the contents which it is currently holding. Hard disk drive, which is a magnetic storage, very popular storage, but it is inherently slow as compared to primary storage, but it offers huge capacity, large capacity as compared to primary storage. As far as cost of storage is concerned, it is much lower, and cost of storage per bit is very low in case of hard disk drive. Another very cheaper secondary storage medium is optical disk, which is either a CD compact disc or DVD digital versatile disc or a Blu-ray disc, which uses optical technology or laser technology to read or write data to a reflective surface. So many of us make use of these discs, which are very less expensive, but they offer high storage capacity. In recent times, this SSD, solid state drive, it is becoming very popular, although it uses IC, integrated circuit semiconductor technology for storage, but due to faster development in semiconductor technology or IC, these technologies are becoming cheaper. So now SSDs are becoming very popular for secondary storage medium. It's a flash memory based device. It is very fast as compared to hard disk and optical disk, and it is very reliable. It does not lose its content, so it is not like RAM. It is in fact electrically erasable programmable memory, and it is very energy efficient, but relatively it is very expensive as compared to hard disk and optical disks. The tertiary and offline storage, cloud storage, which is becoming very popular. Here in this case, the medium can be anything which we discussed just now, but majority of those medium, they were owned by individuals or individual organizations. So the purchase, the ownership is with individuals, right? And its maintenance is individuals' responsibility. But the new concept which is emerging, which relieves the individuals from this kind of responsibility and allows for shifting it to a service provider. So you only take that much which you want and you pay for it. If you wish more, or if you want more, request for more, it is provided on demand, and you use it and you pay for it. So cloud is a storage, is a data storage on a distant or remote server, but most important aspect about it, that presence of a net or internet is a must for it. So using that net or internet, that remote storage server is accessed, and then only it would be possible to store or retrieve data. Examples are Google Drive, Dropbox, Amazon S3. We all know about it. Network attached storage, NAS, which is a dedicated file storage system which provides access to data over a network to only authorized users and devices. And it enhances collaboration, it provides scalability and accessibility. So, I have a storage device, I make it available in my department for the access of others, and only authorized users can access it for storage and retrieval purpose. That arrangement is known as NAS. A storage area network. Now, a bigger picture. It is a high speed network of storage devices. It's a network of storage devices that provide block level storage to servers, and these are used in large organizations, in data centers. External drives, we all use portable drives like pen drive or SD cards, or nowadays portable hard disk drives, SSDs. Let us have a quick summary of data storage solutions which are available today. Direct access storage, network access storage, a storage area network. We discussed about it. Direct access storage, attached storage, it is used to store directly connected to a server or device. In NAS, centralized file storage is possible, and these files are accessible over a network. SAN, as we discussed, it is a high speed network of storage devices which provide block level storage. The last one is cloud storage, which is internet based, a scalable storage which provides service. You look all four, the data access level. In the first one is block level, file level, block level, file level or object level. DAS, performance wise, high for single device. NAS, moderate, dependent on network speed. In SAN, very high performance due to dedicated network. In case of cloud storage, the performance is variable. It depends on the speed of internet. A scalability, in case of DAS, it is limited. In this case, it is moderate. In case of SAN, it is high. And in case of cloud storage, it is very, very high. Cost-wise, DAS is low, NAS is moderate, SAN is high, and cloud storage, as I just said, that you pay as you go. So, if you pay X amount, you pay for it. If you pay X plus 1 amount, you pay for it, and likewise. Management, in case of DAS, it is simple and local. In case of NAS, it is centralized and easy to configure. In case of SAN, it is complex and it requires expertise. And in case of cloud storage, it is fully managed by the service provider, the cloud service provider. The DAS, the use cases, it is for personal and small scale setups. It is NAS is for home, file sharing and backups. SAN is for enterprises, virtualizations for databases. Cloud is for backup, for disaster recovery and for remote access. Let us see the examples USB drive, external hard disk drives, they are examples. Synology NAS, QNAP NAS, they are example of NAS or network attached storage. Dell EMC, NetApp, SAN, HP 3PAR, they are example of SAN. AWS S3, Google Drive, Microsoft Azure, they are example of cloud storage. Now let us see the pros and cons. The pros for DAS is it is affordable, simple to use. The cons are limited sharing, it is not scalable. For NAS, the pros, it is provides centralized access, management is easy. Cons, limited performance for high demand applications. SAN, it provides high performance, centralized storage. Cons, it is expensive and it is a complex setup. In case of cloud storage, the pros, it is scalable, accessible globally. The cons depends on internet, and there are also privacy concerns which we shall discuss later on.